Hello, everyone. Welcome back. Today, we are going to be talking about inductive versus deductive reasoning. We'll also be talking about the law of syllogism and the law of detachment. So let's get into it. Okay, so first of all, what is the difference between inductive reasoning versus deductive reasoning? So, inductive reasoning is when we look at several examples and we predict what is going to happen in the future. So, for example, my teacher's been drinking coffee every morning the last 5 mornings, therefore, she will drink coffee tomorrow morning. So, it's not a definitive proof, right? Because we never know what else might happen. Maybe the teacher will be sick tomorrow, maybe the teacher will sleep in, and so she won't have enough time to get coffee in the morning tomorrow, and we'll just skip it and grab some water in the teacher's lounge before class. Maybe the teacher will have something else to do that morning or decide to switch it up to hot chocolate last minute. Who knows, right? But it does seem pretty probable that this will happen again because it continues to happen. When we see a pattern, that doesn't necessarily automatically mean that that pattern will continue, but there's a good chance, right? There's a pretty good chance in general that a pattern will continue. Now, deductive reasoning, on the other hand, uses laws of logic to develop a conclusion with verifiable fact. And we'll get into that later because the main types of deductive reasoning that we care about in this course are law of syllogism and law of detachment, which we will get into later today. So, an example of this is if a person lives in San Francisco, then they live in California. For those of you who aren't familiar, San Francisco is a big city in California. Those of you in California probably think that's very obvious, and you know that since you were two. Rachel lives in San Francisco. Therefore, Rachel must live in California, right? So, assuming that it's true that Rachel lives in San Francisco, assuming that that's true, and of course, we know that if a person lives in San Francisco, then they live in California, and we assume that it's also true that Rachel lives in San Francisco, we can conclude that she must live in California, right? It's not possible for someone to live in San Francisco but not live in California, right? That's not really possible. It's possible to live in California without living in San Francisco. There's other parts of California too, like Los Angeles and Sunnyvale, and I forget where else, but there's lots of other places in California. It's a big state for sure. But we know automatically that if someone lives in one of the cities in a state, they must be part of that state. They must live there, right? So we use verifiable facts to come to a conclusion made with logical details, as opposed to inductive reasoning, where we just saw that a pattern was happening and assume that the pattern will likely continue. So here's some other examples of inductive reasoning. Let's say Lana has been going out for lunch every day for the past 30 days. Our conclusion might be that she will go out for lunch tomorrow. Now, again, this isn't guaranteed, but it is pretty probable. Inductive reasoning can be wrong, but generally is correct. Generally, patterns do continue. Let's say, for example, that we didn't look at the label in a popcorn bag, and we just opened the bag. We started eating the popcorn. And let's say the first 5 popcorn kernels were caramel pieces. Our conclusion might be that the rest of the bag will be caramel pieces. Now, this is probably true. We probably have a caramel bag of popcorn if the first 5 kernels were all caramel. However, that's not necessarily the case. Maybe it was one of those ones that has like cheese and caramel, like those mixed ones. I forget what they're called, but there's some that have cheese and caramel in the same bag. However, that is not too likely given that the first 5 were all caramel. We didn't get any cheese if that was the case, but it is still possible technically. Maybe we just got 5 caramel by coincidence and it's actually a different type of popcorn bag. But that said, it seems pretty probable that if the first 5 kernels of popcorn were caramel, the rest likely will be too. It's not too likely that it'll be anything else. Okay, next let's talk about the law of syllogism. The law of syllogism says that given that these are true, that if P then Q is true, and if Q then R is true, then if P then R would also be true as well. So for example, if I stay up too late, then I will sleep in. If I sleep in, then I will be late for school. Therefore, if I stay up too late, then I will be late for school. So if we assume that the first 2 statements are true, then it must also be true that if I stay up too late, I will be late for school. All right? And this makes sense, right? If we assume that it's true that if I stay up too late, I will sleep in, right? That's a conclusion we can make. Then that's the hypothesis for the next one of if I sleep in, then I will be late for school. we can conclude that really it's the staying up late that led to us being late for school in that scenario, right? We can take out the middle one, the middle thing, which in this case is Q, and just go straight to, well, if P happens, then R will happen, right? Because if P happens, then Q happens. If Q happens and R happens, so therefore P is really, in a way, the cause of R, right? So we can take out the middle, the middle statement there. Let's think of some other things for law of syllogism as well. So let's say, for example, if a quadrilateral is a rectangle, then it is a parallelogram. If it is a parallelogram, then the area is base times height. Therefore, the area of a rectangle is base times height. Well, assuming the first two are true, the conclusion must also be true. So let's see, were the first two things true? Is it true that if something is a rectangle, if a quadrilateral is a rectangle, then it is a parallelogram? That is true, yes, because all rectangles are also parallelograms. Now, is it true that a parallelogram always has base times height as its area? Yes, that is also true. So therefore, it must be true that a rectangle also would have base times height, because a rectangle is a parallelogram. All parallelograms have base times height as their area. Therefore, base times height would also get us the rectangle's area. And that may be something we already knew as well, perhaps, but that's just another example of law of syllogism working. Okay, here's a couple more examples. If I study for the test, then I will get a higher score. If I earn a higher score, then I will get $20. Therefore, if I study for the test, then I will get $20. So if we assume that it is true that studying will lead to a higher score, earning a higher score will lead to us getting $20, then studying will lead to us getting $20, right? Because it will lead to a higher score, and the higher score leads to $20. So studying is where it all starts. That studying is where it will lead to us getting $20. Here's another example. If an angle is 5 degrees, then it is an acute angle. Well, that is true, right? We know that all angles that are between 0 and 90, not inclusive, are going to be acute angles. We also know if an angle is acute, then it is not obtuse. That's also true because acute angles are less than 90 degrees. Obtuse angles are more than 90 degrees but less than 180. So it is not possible for an angle to be acute and obtuse. An angle is either acute or it's obtuse or it's some other type of angle like straight, right, or reflex. Therefore, if an angle is 35 degrees, then it is not obtuse. So we can verify this in two ways. First of all, of course, we know that if an angle is 35 degrees, then it's not obtuse, just by the definition of it being, 35 degrees. We know that obtuse angles are greater than 90, so that's not going to be the case. However, the other way we can verify this is true is because we verify the other two are true, and we can use the law of syllogism to say, okay, therefore, it's not going to be obtuse in this case that it's 35 degrees. If it's 35 degrees, it can't be obtuse because the other statements were true. And we know that if P, then Q, and if Q, then R, if those are true, then if P, then R is also true, right? And so there's two ways we can verify it, right? The regular way and also with the law of syllogism as well. Okay, let's talk about the law of detachment. So if these are true, if it is true that if P, then Q is true, and P is true, then we can conclude that P is true. So for example, if Brenda lives in Orlando, then she lives in Florida, which for those of you who don't know, Orlando is a place in Florida. Um, so yeah, so let's just take that for granted that we know that Orlando is a place in Florida. So if Brenda lives in Orlando, then she lives in Florida, right? Which that is absolutely true. We know that that's true. If someone lives in Orlando, they live in Florida. Now, then this next one says Brenda lives in Orlando. Now, assuming that's not a lie, assuming Brenda's not lying to us about where she lives, assuming she really does live in Orlando, then we can include, okay, then she lives in Florida because we know that all people who live in Orlando live in Florida, right? Again, we can't be part of a certain city that's within a state and not be part of the state. That doesn't make sense, right? So yeah, so there we go. There's an example of law of detachment. So here's another couple of examples. If someone works at the bar, then they have a smart serve certification, right? So let's assume that that's true, right? That if someone works at a bar, then they have a smart serve certification. Okay, great. Alex works at a bar. Again, let's assume that's true, that she works at a bar. Therefore, Alex has a smart serve certification, is something we can conclude, right? However, something I want to mention too is that just because the conclusion's true does not mean that the hypothesis is true. So, for example, let's say they said if someone works at a bar, they have a smart serve certification. Alex has a smart serve certification. Does that necessarily mean she works at a bar? No, right? Just because someone has a smart serve certification, it means they're certified to work at a bar. It doesn't mean that they actually do, right? Based on what is being said here. So we can't say that, assume the conclusion is true and use that to say that the hypothesis is true. It only goes one way, right? It only goes the way that if P then Q, P is true, so then Q is true. If we know that if P then Q, and we know that Q is true, that does not necessarily make P true. It means P could be true, certainly, but not always. Not always, because it's not biconditional. Here's another example. If a shape is a quadrilateral, then it has exactly 4 sides. A parallelogram is a quadrilateral. Therefore, a parallelogram has exactly 4 sides. So again, this is the same pattern where we are saying, okay, if a shape's a quadrilateral, if this is true, then it has 4 sides. So then that's true, right? Then we're saying, okay, the first one's true. This thing, it's a quadrilateral. Well, therefore, we can come to that conclusion that it has 4 sides because we know that all quadrilaterals have 4 sides based on what was said in the beginning. So yeah, so that is all. That is the law of detachment, law of syllogism, and just an overview on inductive and deductive reasoning and their differences as well. So I hope everyone learned something, and I will see everyone next day. Bye, everyone.